Okay, go ahead and do the warm-up real fast. Graph that linear inequality. Guys are fast.
When is it dotted line?
Mm-hmm. Yes, should be a dashed boundary line since it is a strictly less than, strictly greater than. Okay, and then did you shade above or below? Below. Below. Did yours look like that? Yeah? Cool. All right. So we are not really doing anything new. We're just looking at dealing with multiple linear inequalities at one time to create a system of linear inequalities in two variables. Okay, so you're considering the solution sets to a linear inequality in two variables at the same time as you're considering other solution sets to all of the other linear inequalities that are in the system. And remember, the solution set to a linear inequality was infinitely many points, or half plane with infinitely many points that would satisfy that inequality. You want to join us? I only have 3 people today.
That's okay. I don't like this stuff.
So the solution set to a system of linear inequalities will also have potentially infinitely many points, but it's going to be where all of those solution sets end up overlapping, or the intersection of all the solution sets. So for example, okay, if we're looking at this system of linear inequalities, like thinking about each half-plane solution set for each of the inequalities that's part of the system, the actual solution is where those two, where the shading ends up overlapping. So like here, this is the solution, right? Or here, I'll use like purple, dark purple. Okay, so everything in here where the shading overlaps, and this line would also end up being part of the solution set too, or points that lie on that line because it's where it overlaps.
So in this case, where they intersect not be one of the points because the line is dotted?
Correct.
Okay.
Yeah, so it has to be that every point, a point has to satisfy each inequality that's in the system, in the same way that a system of equations did, right?
So they both have to be solid lines.
Well, so we could choose points that are on the solid line that are also, right, because at least from above the point of intersection on, because each of those points would end up satisfying each of the inequalities. It's just that point of intersection that does not. Like that point of intersection looks like it's what? -4, -6. So if we were to go back to the inequality, like if you plug in -4, -6 here, -6 is greater than -4 minus 2, you'd get -6 is greater than -6, and that's not true. But it would satisfy this inequality. Does that make sense? Are you guys okay with that? Are you okay with that, Owen? Okay. So really, again, nothing new. Your interpretation of what the solution area is. And remember, the whole point of graphing a solution set to a linear inequality in two variables is to give you a visual representation of what the solution set is. So it's the same idea with a system of linear inequalities. Sorry, it's been a long time. So we want to graph each of these inequalities. We can do the shading, and then you just want to make sure it's really clear what the solution set is. So I'll show you how you could do that. So like if we think of numbering each of these inequalities, like if I take the first one and then rewrite so that the boundary line is in slope-intercept form, you can think about graphing that. So y-intercept of -4. That first inequality would have a dashed boundary line, right? So slope of +2, right one up 2, right one up 2, right one up 2. You can also hold off shading anything until you've graphed both boundary lines, and then just think about shading the appropriate region. Or you could do this. So like, would we shade above or below for this inequality? Above. So to kind of use what we already know. And then maybe I'll do green for the second one. So taking the second, oops. So -6y is greater than or equal to -3x. So getting that boundary line into slope-intercept form, remembering to flip the inequality when I divide by -6. And then graphing that. So up 1, right 2, up 1, right 2, up 1, right 2, up 1, right 2. Solid boundary line, and then shading would be above or below. Okay. So making sure it's really clear where the solution set is, the overlap is here, yeah. And there's infinitely many points, like the lines, those boundary lines will continue on if you imagine the plane continuing on. So it's kind of a wedge of the plane that ends up being the solution set with infinitely many points. An application of these is, I mean, it can be used to solve different problems. Like I think, did I put some on here? I think this a while Yes, I put some. So it can be used to solve some types of problems, like whenever you're looking for like a range of values and you can relate the quantities still with a linear relationship. But its biggest application is probably something called linear programming. Have you guys heard of that before? Linear programming? Like it's optimizing. Like it's trying to optimize a quantity. And this using systems of linear inequalities can be used in particular, like the vertices or the points of intersection of the different boundary lines. We're not going to do it in here. It's probably something you would look at again in Algebra 2. Did you guys do systems of linear inequalities last year?
Yeah.
The systems part? Yeah, you did. Word problems too.
I don't remember word problems, like specifically, but I remember this.
Didn't
Word
do word
problems?
problems for the linear, the systems of linear equations that you said.
The word problem's the hardest part.
Well, it's definitely the hardest, but do you remember if you did it last year?
I remember them, but not for
Not for
these.
these,
Yeah.
okay. Why don't you guys do this one? Go ahead, try and graph the solution set, compare your answers with each other. No. It's not cold. No, she wants it off.
It's like perfect.
It would be stuffy without it. You're funny, Gabby.
Wait, when you divide by a negative, you have to switch the thing.
If you divide by or multiply by a negative, yes.
Apparently, so the sign switches. They're parallel, right?
Are they? I switched it.
Why do you shade like that? I don't know.
Let me see.
Wait, no, I messed up. It's like, oh, it's like this.
Oh, it's okay. I graphed it still correctly.
I feel like
You should see his, it was just like this.
No, it was better than that. You should scribble it through.
Energy cheap.
blocks.
Salted watermelon.
He's the monkey.
Try the next one. Oh, wait, so what, actually, before you go on, so then what do we say about the solution set?
No solution?
There's no solution. It's an empty solution set.
Is there a set for
No
next year?
solution.
For like in geometry, is it gonna be like us 5, or are we gonna be like mixed with freshmen?
You mix with freshmen,
Okay.
unless you take geometry over the summer.
Yeah, wait, do you have to, also, do you have to get like, a certain grade in this class to do geometry and stuff?
I think so.
Or does it have to be?
I don't know off the top of my head. I have to check on what the requirements are for summer. Because it's really condensed. Like she moves at a really fast pace.
Who does it?
Miss Bertrand. She's the geometry queen.
It's
What?
5 weeks, right? 5 weeks.
Was it 4? Because I do the bridge class and it's
I thought it was
3
6.
weeks. So I think that, but maybe it's 4 or 5 weeks.
Over the summer?
And like June. Right after finals. But then, if you want, it depends on what your goals are. We'll talk more about this as we go into second semester. But, oh, I'm not showing anything, please. No solution, right? There's no overlap, so no solution. This is an empty solution set. Okay. Because they're parallel lines that overlap. Now, let's say that for this one, that like you shaded above, then all the overlap, there would be solution sets, even though you have parallel boundary lines, and the solution set would just be all the points that are in this shaded region. Okie dokie. Oh my goodness. 3 inequalities. Go ahead and graph each of those inequalities and do the shading. Let's see where they overlap.
Oh, is it vertical or horizontal for the?
It's horizontal.
Horizontal. Y equals -4 is a horizontal line. All the points where y is equal to -4. Okay. Oops. Now, the biggest thing with graphing these systems of inequalities is making sure it's clear to me where the solution set actually is, which I'm not doing the greatest job of right now. Okay, and then let's do orange.
I'm pretty sure this is it. I don't know. It looks all messed up though.
What shape does your solution set make?
Triangle.
Triangle.
Yeah, it's kind of good. Yeah, it looks like it. But mine just looks.
Like a mess.
Yeah.
Yeah. So this is where, like, if you can, it's maybe a little bit better to wait until you've graphed the boundary lines and then figure out where they would overlap. Like, the solution set would end up being within this triangle. As well as on those boundary lines where the points would be included as part of the solution set.
That looks beautiful.
I know, mine looks like.
What?
I don't know why.
Dude.
See, I told you that's. Like I said, look at how Owen shakes his thing.
Looks like a 4-year-old.
I can't, I'm telling you right now, I cannot tell.
That's
You guys look.
I'll change the shape.
Look. You could just
Yeah, I'm
like erase after. That's kind of nifty. And where do we got? Okay,
I'm gonna shade this.
go ahead, do this next one.
A little bit. Shade.
But nothing really new, except for we're kind of putting together like the idea behind the solution to a system, and then with our knowledge of what the solution sets to linear inequalities are.
I'm just gonna leave it like. It's gonna look weird. No, it's gonna work.
I can tell you though that if you did take geometry next year, that you would be with high schoolers, like you wouldn't be with any junior high, if that was a concern.
Yeah. Oh, wait. Whoops.
Did you whoops or did I whoops?
I did. I got the same thing as you. So if you whoops, I whoops too.
All right, I didn't,
Come on.
I don't think I
I'm
whoopsed. Here.
Yeah, I can't shade it. It's not my fault. It's my app pencil's fault. 'Cause every now and then it just like skips out and it looks all weird. Like, I don't know how to explain it.
I almost like it better with the shading.
This is good. It's fine. Right.
What do you mean it's skipping out? Like it like stops like right for a
Like,
second?
yeah, it would do this and then it looks like.
Just like
Then it looks
Okay.
like weird overlap.
Well, actually, why not? Why not? Go ahead, do this one. Now, this one, that first inequality, the boundary line would be
and Y axis.
Or vertical.
Right, it would be vertical.
It's straight in the middle.
Yeah, the y corresponds to the y-axis, and then you would be shading to the right. Thinking like number line. Where would x values be
I'm
greater
just gonna do that.
than 0?
It's because I've drawn my Apple Pencil so many times that like this tip part of it is all like messed up.
You know, I think that they have other tips downstairs. Mr. Bates has
There's
some.
like the third one I'm counting. It
Okay.
just falls out my iPad.
And then we would have y. Oops, no, that's not what I want. Y is greater than negative 5x plus 5. I think I need to restart my iPad because my Apple Pencil has been glitchy today. Interesting. Okay, so the solution set would be everything over here. Mine's gonna not look so good either. And then in here, that looked ugly. Get rid of it. We can make the shading bigger. There we go. Okay, just make sure whenever you're doing it by hand, like just like lightly shade and then just darken with the pencil, like where, make sure it's clear where the solution set is. What do you guys think about this one? Construct a system of linear inequalities. So that means you're coming up with what the system would look like that describes all the points in the first quadrant. Yeah.
X is greater than 0, and then y is greater than 0. Or greater than. Or
It says
greater
in
than
the first-
equal to, right?
Well, it just says in the first quadrant. It's not actually like points that lie on the x-axis and y-axis are not actually in the first quadrant. So I agree with your first statement. X greater than 0 and y greater than 0, right? Like if you were thinking about just Q1, your x-axis, your y-axis, and you're thinking about what would represent all these points in Q1. This is Q1. I agree. Okay. Do I want to? I'm gonna try one of these. All right, Becky is a full-time college student with 2 jobs. She can work no more than a total of 10 hours each week. Dog walking pays $5 per hour and babysitting pays $8 per hour. She needs to earn at least $56 each week to pay her bills. Write and graph a system of inequalities that shows the various numbers of hours that Becky can work at each job. So what should we define our variables as, you guys? What should we let x equal to?
Dog walking,
What about dog walking?
hours,
Number of hours of dog walking or time dog walking in hours? Time dog walking in hours. And then Y would be time babysitting.
Yeah.
Okay. So she can work no more than a total of 10 hours each week. So what's an inequality that we could come up with that would represent that statement? Yeah, Ellie.
X plus Y is less than or equal to 10.
Yeah, because she can work a total of 10 hours. She just can't work any more than 10 hours. So the amount of time dog walking plus the amount of time babysitting should total no more than 10. Okay, and then she needs to make at least $56 each week. So we would be thinking about how much she could make from dog walking plus how much she could make from babysitting. That has to be at least $56. Ideas?
5x plus 8y is greater than or equal to 56.
5x plus 8y is greater than or equal to 56. Yeah. Because 5x would represent $5 times X number of hours dog walking. That would be the amount she'd make from dog walking. Plus $8 times Y number of hours of babysitting would be the amount she'd make from babysitting. Okie dokie. And then we can go ahead and graph. So Y, I'm going to make that Y. I'm going to number these. My Apple Pencil's not working. There we go. So I'm going to call that inequality 1 and inequality 2. So if I take inequality 1, okay, and then labeling, you want to label what each axis represents. So I'm just going to have each tick mark be 1. So 1, and we said X was time dog walking.
Wait, X plus Y is less than or equal to or greater than? It's greater
Plus.
than.
And then Y is time babysitting. Make sure you're labeling what each axis represents. So I'm scaling. Okay, so tan, and then a slope of -1. And then shading below would be for that first inequality. Here, maybe I can just use like a really light green. And then for the second one, I'll use a different color. So second, we'd have 8y is greater than or equal to minus 5x plus 56. So negative 5/8 x plus 7. It's being so glitchy. Minus 5/8. So down 5, 1, 2, 3, 4, 5. To the right, 8. Okay. Well, that's not actually a point, but it's trending that way. So then we would be shading above. So you'd be shading above for the second inequality. So we can actually see that the solution set would be everything in between here or on the boundary lines. So you could pick two different points as combinations for what would meet the criteria. So for example, she could work, what's her name? Becky. Becky could work 1 hour dog walking and 7 hours babysitting.
Wait, for the one you shaded blue, aren't you shading just up? So how would it intersect with the other one? Oh, never mind.
It intersects here, right? Because it had a y-intercept of 7
Oh yeah.
for the boundary line.
Oh yeah.
So it's just pick another point. It's another possible solution. I'm not going to assign too many practice problems from 5.5. You guys do have your quiz next class on 5.4, 5.5. I think 5.5 is kind of easy.
So it's just gonna be like all work on
Can you put the whole test on 5.5?
No, because some of these will be on there. Okay. Oops.